Good morning, everyone. It's time for polynomial functions video number 8. We're talking about polynomials of an even degree. But before we do that, I'll flip back to the last video. That was yesterday, so I want to do a review. So remember, number 1, degree is the highest exponent in your polynomial. Doesn't matter whether it's the front, middle, or back, don't care, but it's the highest one. If it's an odd degree, you're going to have 2 choices for your end behavior. If A is positive, right? So the leading term, which is the one with the biggest exponent, the number in front. If A is positive, there we go. It's going to be going uphill. If A is negative, it's downhill. And it doesn't matter. My goodness, that got messy looking yesterday. It doesn't matter whether it's x to the 1 or to the 3rd or to the 7 or 5. Those are the rules. All of these except the oops go uphill. These ones go downhill. So there are people out there who are way smarter than me or have a way better memory. And they can remember that if it's an odd positive, it'll start in 3 and end in quadrant 1. And they just know that. I don't. What I remember is, yeah, it goes uphill. So if I have to do this for an assignment or something, I'm drawing myself a little sketch just like this. And oh yeah, 3, 1, check. We're good. Okay, so today for this video, we are now looking at polynomials of an even degree. Things are a little more interesting. Before you just had a hill. No, you didn't have that. You just had a road and went uphill, downhill. End of story. However, with even degrees, you get they're parabolas or something of a parabolic shape. So that's that curve. So parabola is the actual shape. The equation that we usually base it on is a quadratic. But the key thing is it's an even degree. So this one, if A is positive, and I'm so glad it works out this way, then you get a little bit. You get a lovely smile. You can also describe this as opening upwards, right? Goes that way. And it has a minimum. And the minimum means that's as low as it goes. So in this case, on this diagram, the minimum is 0. You can also have ones that like that. So then you've got a minimum that's negative. And you can have ones that are way up here where the minimum is positive. It doesn't matter. And while I actually have those diagrams there, every single polynomial function that we look at has one y-intercept. This one, the original one, is super easy. It's 0, 0. It's the x-intercept, it's the y-intercept. Bada boom, bada bing, we're done. One like this, now, these lines always have arrows on them because they keep going. So if this line keeps going, excuse me, and hold on, I'm trying to find a ruler. Rather trying to pick it up because I have no fingernails. Boop. If we extend our y-axis, it will cross eventually. Now there's no grid on here and I'm just sketching, so, but it's once. But the cool thing is it'll have 2 x-intercepts. And then this little guy over here, if I extend it, oh, we're gonna run out of room again. It's gonna cross, oh, off screen too, eventually. Oh, I should say these keep going this way too. It's not like they just go off in one direction. But this one doesn't have any x-intercepts at all. And that's okay. So with these, you can have 0, 1, or 2, because I think we're only going to go to quadratics, but that's kind of getting into the next little section. Anyway, there you go. If A is negative, you get a maximum. So again, same deal. Maximum is going to be as high as it goes. It opens down, and I just call it a frown. This is probably, I highlighted the other side. There we go. And it's the same as before. There might be weirdness in the middle. I drew these. These are just like, this is probably y is equal to minus x squared. And this one over here is equal to y is equal to x squared. Okay. So the negative is going to make it open down, and that's going to give us a curve. When this is like the power of 4, then you might get, just sketch, it might go something like that in the middle, or a higher power. No stress, it's all good. Okay, but you're still going to have 1, 2, 3, and 4. So it's either going to be 3 and 4 when it's negative, or 1, 2, 3, 4. Whoops, that's all messed up. There we go. Boop. And it's going to be 1 and 2. So some examples. Oh, look, I wrote that down there. I'm going to do the same thing as before. I'm just going to highlight my leading terms. So some of these aren't bad. Boop, boop. So the 4 is the highest power. I should mix them up more, but too late. It's the 8. There we go. I'll do the same thing here. Oh, it looks like it's the same set of equations. So one side's negative, one side's positive. So all of those are even numbers. And again, they can do weird things in the middle, but we can always figure out where the ends are going to be. So I'm going to do what I did last time. I'm going to stop my share. I'm going to flip over to Desmos, and we'll actually take a look at some of these. So we all make sure we all understand what's going on. There it is. There's my friend Desmos. All right. Whoops, not these ones. Let's go in order. I should have done the positives, looked at the graphs, then the negatives, looked at the graphs. Oops, live and learn. All right, so there's the simplest one. We'll zoom in a little bit. Okay, so it's squared, which is makes it a quadratic equation, and the shape that it forms is a parabola. So if we just have x squared, there it is. A is, ooh, what's A? A is 1, right? Let's try this. What if I put a 1 there? And we hit enter. The answer is absolutely nothing. Okay, let's throw in a 3. You can see when I put a number in front, it actually gets a little bit skinnier. Yeah, I don't know how else to say that, but it gets skinnier. And if we put a 5 in there, oh, all sorts of stuff happened. But it's still that same shape. It's still starting in 2 and ending in 1. Okay, so this plus 12, basically all it does is move stuff around. So this one is really cool. I was looking at this and I played around with it for a while, and I'm like, okay, what's wrong? Because that's not the right shape. And I retyped it more than once, honestly. So I'm like, what the heck? It's supposed to be a parabola. This looks more like some kind of a negative odd degree. I'm like is Desmos lost it? Do I not understand something? And then a little brain cell said, you know, what if you zoom out And if you zoom out far enough, oh, I don't even know how far I'd have to zoom. Let's see. Oh my. Somewhere, I may give up soon, because we're at negative 16,000. Okay, somewhere down there, it changes direction, is my point. So if we get back to the middle, oh, I wish there was a resetter button. Okay, let's zoom back into the middle where it was interesting. So when I first did this, that's all I saw. And I'm like, that's an odd degree because it's supposed to, you know, do this. But like I said, when I went over here, oh, there's the rest of it. So somewhere way far down in the bottom, it turns and comes back up. There are mathematical ways, excuse me, to determine that, but they're not part of this course, so I'm not going to worry about it. But I just thought that was very cool. So that's something to the fourth power, but it's still got that same shape. This is, look at all of that stuff to the sixth power and the fifth and a squared and all. Really doesn't do that much to the shape, does it? Just kind of a parabola. Okay, let's do 8. Okay, pretty much the same shape. We'll look at that. Oh, that one's, well, still not really exciting. It's a little more flat at this point, but so there we go. You're starting in 2 and ending in 1. But oh, I want to show you something else that I figured out. Let's go back to this one. Let's get rid of this guy. Okay. And you know what? In fact, I don't even want this one. I want this one. That's the simplest one. That's just y is equal to x. Sorry, y is equal to x squared. So that's our very first even degree. And if I start playing with this, so get my screen a little closer here. Minus 2x plus 5. Right? I can move stuff around. Instead of 2x, if I put 6x, I'm going to zoom out a little bit. Okay. And I put 3, or put minus 10. It's all just pretty much that same smile. I'm just moving around a little bit. Okay. And in fact, if I put 2 there, I can make it skinnier. If I put 6, it's going to be super skinny, but it's still the same shape. But the moment, dun, 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 watch for it, I make it negative, whoop, it disappeared. Well, it didn't disappear. It went the opposite direction. See that again. Ready? It's negative. Oh, sorry, hit the wrong button. So that leading, the sign of the leading term determines which way it goes. Pretty cool. The only way I can change my, whoops, see if I can do this. It worked earlier. To change my shape is if I put another x in. Now, this, hope you can see this. Get closer if you need to. Looks a little ridiculous. It's 6x x squared, so it's x to the third. It was just faster to add x's than to redo with the exponent. Now my shape changed. Okay, look at that. Take it out. It's a parabola. Put it in. It is something to the third power. You know, it's got a wobble. But wait, there's more. I'm going to add another x. Whoop. There it goes. Goes back to that shape. You know, there's other things happening. This seems to be moving a little bit. This is doing things. But it's those two things that determine the basic shape of these. It's the sign at the start and the power of x. Okay, let's back to that. Let's see what happens if we put an x here. Oh, Okay, that was ridiculous on my part because now I've got 6x squared minus 6x squared, so the x squared is disappear. We just have minus 10. So I'm going to make that a 7. There. Still got a problem. But hey, that one's cool. If we count here, there's 1, 2, 3, 4. So this is x to the 4th. So that's my leading term. And it's negative, so it opens downwards. I've made myself a McDonald's sign. I'm so pleased with myself. Okay, enough playing. I'm just going to scoot down to this one. So, whoops, move that a little bit. It's the same set of equations. If I go negative, they're going to start in 3 and end in 4. So here we go. Excuse me. I'll zoom out so we can find the top of that one. And here's that weird one again. The one that freaked me out the first time, but I've now learned. Oh, where'd it go? Somewhere. Somewhere in here is the rest of the green line. Oh, there it is. It's over there this time. Okay, so it's still starting over here in, oh, wait a minute. Do this right. Oh, no. Okay, so now we're going to have to go up to like 10,000 or something to find that. Don't worry. I'll make sure if I give you something like this, it'll be on the graph, not guessing which way it goes. Enough of that. All right. So then, oops. Where's that one? Where'd I go? Lost our graph. Oh, I'm going the wrong direction. Not bad. There it is. Oh, look, it's got a nice little wobbler. All right, but negative 6x 6. Oh, I want to try something. What if it's going to go crazy for a little while? Take all that stuff out. It's still pretty much that same shape. There was some weirdness in there as terms combined accidentally. Let me try that again with this one. Where'd it go? This one. Oh, over to you. Okay. So we have 12 to 8. I'm going to take this all out at once. Delete. I really didn't do much, did it? Now I'm going to take all of this out at once and delete. See, hardly any difference. You know what? It's a little bit like being a millionaire. If you lose a couple of quarters, it's not going to make a big difference in your life. Actually, what I just, although it's a silly example talking about money, that's actually some of the basis of calculus. One of the things you have to determine is so for example, the limit of negative 12x to the 8th, that's what we say in calculus, as x goes to infinity. So as x gets super duper large, in this case is probably going to be infinity. Okay, that didn't help you at all. So if we look at this example up here, right, I'm doing a little calculus for you and then I'll get back on track. If you start making x really, really big, what happens is this x to the 4th part is going to overpower everything else. It's not going to matter how big those ones are because this will be the big one that you notice the most. Okay, enough. Let's stop that share and get back to where we should be. All right, so I know this said page 1. So I want you to look at this. There's nothing really to do other than memorize. Memorize, 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 memorize. Or, no, memorize. Yeah, I know. You can just put it on your sheet. So what you need to know for end behavior. So this is end behavior. Ooh. Yes. of polynomials. Oh, wait, do it right. Polynomial functions. There we go. So the first thing I do is I look to see if my leading term is odd or even. If it's odd, I know it's either going to be uphill or downhill. If it's even, it's a smile or a frown. Second thing is I look at the coefficient, the sign of that coefficient, and then it goes from there. So if it's an odd one, so this is how my brain does. If it's odd, okay, it's going to be a line. It's either uphill, downhill. And then I look, if it's odd positive, it's uphill. If it's odd negative, it's downhill. If it's even positive, it's a smile. And if it's even negative, it's a frown. Ta-da! And once you have this diagram, a little sketch that you're going to draw, it becomes super easy to figure out what quadrants your start and ends are. I find, like I said, I find that way easier than trying to memorize everything. Just a little note that says read the graph from left to right all the time. And when you're done, I'm begging you. I'm begging you, people. I'm begging you. When you're done, if you've got a long sheet where you're finding the starts and ends, just take 3 seconds and go, all of those answers should be either 3 or 2. And all of my ends should be either 1 or 4. Okay. And just double check. My brain said, wait a minute. I'm like, nope, this stuff's good. This is golden. You need to know that. And just check. I've just finished marking some stuff, and there's a few people that had mistakes, and I'm like, why would you throw away those marks? It's so easy to do a double check. Okay, and now it says we need to complete the chart. That is part of PF6. All right, let's see if we can find it. Oh yeah, there it is. All right, so let's see, there's more. Hold on. Oh, there's the other page. Okay, so we're going to use this information. I need to rearrange my workspace. And oh, I haven't hit myself for doing this. Okay, so go back to this page. We talked about what a polynomial function was, and we did the vocabulary, and we did the nice little chart. And I said, don't worry about this stuff, because we don't care at that point. Now we do. So what we're going to do is compare this, bring this down to the chart. Okay, so my first one, degree is 2. I think I'm maybe doing a lot of shifting here, and my apology if I'm not on screen. Okay, so degree is 2, so I'm down here. I know it's a smile or a frown. Leading coefficient is 3, so it is positive. Boom, it's a smile. All right, so number 2 here, degree is 1. So I know it's 1. We'll get there. It's going to be either, so it's odd, and the leading coefficient is 5, which is negative. So it's downhill. That's all it is. But based on this, you can determine the starts and the ends, which is the whole point of this, right? The title said end behavior of polynomial functions. So we're only worrying about the start and end. What happens in the middle is just fine. We don't have to worry about it. All right, number 3. It's my degree is 8. So I want to go, it's going to be one of these two, and it's positive, right? Because the leading coefficient is 3. So that's a smile. Boop. All right, negative 3x cubed. So cubed is going to be odd. And it's negative. So downhill. Remember when you read, we read this way. When I say downhill, that's what it means. Okay, so we got x to the 1. So the degree is 1. The coefficient is 1. It's positive. There we go. And the last one, the last one is squared. So it's even, it's positive. That's a smile. And in case you're wondering, this calculated in the constant, we just did that because it actually doesn't have anything to do with this. This will become important later on when we're trying to find the y-intercepts. So being able to find the constant saves you some time. Pause the video and do this page. All right, I hope you did. I'm not going to keep referring to the chart because it's just, it's click, 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 click for me. I don't want to do that. All right, so degree 3, that's odd, which is uphill or downhill. It's positive, so that's uphill. There we go. Our leading coefficient here, our leading term is x to the 4th, so that's even. So it's a smile and a frown, smile or a frown, and it's positive. So that's a smile. 1/2. Ooh, look at that one. There's my degree of 2, so that's even. My leading coefficient says it's a half, so it's positive. That's another smile. So this is a cubic x to the 3, so that's odd. And we're still positive. So it's also uphill. Now we have x to the 5th. So 5 is odd, 3 is positive. We're going uphill again. Oh, and again. This one, it's 2, so it's even, so smile or frown. And 9 says it's going to be a frown. And number 10 was a ridiculous question. It's actually going to be a horizontal line. Probably should take that out of there, but it's in the video now. All right, awesome. Sorry if this was a long video, but I hope you have a deeper understanding of what's going on now. Have a spectacular day.